So what is integration by parts? So far, we did not discuss anywhere we have a product of multiple functions. For example, in case of differentiation, if we have a product of two functions, f of x into g of x. So yeah, this is what we are not seen, right? So if we are differentiating product, we have a rule, right? That is u into dv by dx plus v into du by dx. Similarly, we want to know how to integrate the functions which are having products. Okay, so let's see what are we going to do here, the concept part. So please pay attention to this. It is a technique. What is integration by parts? It is a technique used to evaluate integrals of product of two functions. The product of the integrals of the two functions is given as, suppose u is the first function and v is the second function. So let us replace it as f of x and d of x. See this explanation. It says integral of product of two functions is equal to product of the first function as it is into integral of the second function minus integral of differential coefficient of the first function, that is differentiation. After doing that, we are rewriting it. This entire thing we have to put a bracket, yeah, into integral of g of x, x. So meaning the first function, second function, I'll tell you. But for now, f of x, g of x, dx integral is given as, you write the first function as it is. Now integrate the second function with respect to the given variable minus integral of, in the bracket, f dash of x integral of g of x dx. What is the step? All this is explained here. If you are able to understand, fine. Others, just remember this formula. Whenever you have a product, you have to do this. But first function and second function, we cannot randomly choose. There is an order in which you have to give the preference. This is the order I, L, A, T, and D. What is I? Inverse trigonometric functions. What is L? Logarithmic function. What is A? Algebraic function. Like Brodmann's, we have a rule, right? Bracket of division, multiplication, addition, multiplication, addition, subtraction. Same way, this is the order in which we have to go. T is for yes, trigonometric function, and E is for exponential function. Whenever you have multiple functions, okay, so we have to prioritize in such a way that first, if we have all this, any one of them, whenever you have inverse, that is treated as a first function, anything else will become second function. If you don't have inverse, then logarithm will be the first function, anything else will be the second function. Suppose if you don't have logarithm, if algebraic will be the first function, remaining will be the second function, that is trigonometry and exponential. So least one is exponential. That will be the last one we always take. And there is a reason for all these things, because as integration is a inverse of differentiation, when we use this order, our rule of differentiation, inverse of differentiation, satisfies the given integration. So that is the reason this has been proved and then and is being uniformly followed throughout the world. So this is how we do the integration. Okay. So any question here in this order? I'll repeat again. ILATE, I for inverse trigonometric function, and then L for logarithm function, A for algebraic functions, T for trigonometric functions, E for exponential function. Remember this abbreviation ILATE. Let's see some example. Then only it will be clear for you, right? Yes. See, if two functions, one of the different type takes that function, first function which comes first in the word in the first in the word ILATE, then remaining will be the second function. Explain this. Let's take an example. Okay, so before solving this, there is one more part. What if it is of this form? Whenever you have an integral of this form, integral of e power x into f of x plus e power x into f dash of x, entire thing with respect to x. This will be proved to, see this will be directly proved to e power f of x. So after combining all this, we can prove this as, here it is the statement. The statement you can just remember, whenever you come out with a function like this, e power f of x plus e power x into f dash of x into dx. So we can directly write as the result as this. It has been proved already. Okay, so by using parts, integration by parts only, we can solve this. Okay, so please check the proof later. So I am trying to remember this formula. Whenever we come across exponential function, multiply to two different functions. If one of them is a differentiation function of the other one, we can directly use this. Okay, so let's show an example. Yes, let me show this example. See this. We have a question here, integral of e power x into tan inverse x plus e power x into 1 by x square dx. Here you have to observe this 1 plus x square is nothing but what? It's nothing but what? D by dx of what? Tan inverse of x. So this is nothing but integral of e power x into f of x plus integral of e power x into f dash of x. This will be simply integral of e power x into f of x. Okay, so I mean that's the final answer. The final, I mean, not integral, it's simply e power x into f of x. That means the answer to this question is simply e power x into what's the original function? Tan inverse of x plus c. Okay, yes. So we have 4 questions in this part. Okay, yes. So what is it? Integral of log x. So far we did not come across this simple question, integral of log x, because we did not have a technique. Now we have understood the technique. So integral of log x can be solved by integration by parts. What integration by parts is? We have to consider the order I, L, A, T, E. But we have only one function here, logarithm. So there is always one hidden, right? It can be this into 1 into dx. What kind of function is 1? 1 is a algebraic function with a degree 0. So I am treating f of x, that's the first function, as logarithm of x, second function as logarithm of x according to the priority, second function as 1. Okay, now according to our rule, f of x into g of x dx, we will write the first function as it is, integrate the second function with respect to given variable, minus what we do minus only, right? Integral of f dash of x in the bracket, integral of g of x, yes, dx plus the constant whatever. So applying that rule, what will happen to our problem? So f of x is what now? Log x and integral of 1 dx minus integral of what is a differentiation of log x? 1 by x into integral of what is that? Uh, that x, g of x, right? Into dx. Okay, so what will happen to this is this cancel out. So we get x into log x minus x plus the constant c. So we can take the x common. We get logarithm of x minus 1 plus c. So which option is this? Can you check? Let's see the answer. So that is option C, right? So our option is clearly matching with our answer. Isn't it easy? It must be easy. Let me quickly solve the remaining 2 questions by this method. So this is an interesting question where we have to rearrange this. So this is given as integral of e power x logarithm of x plus 1 by x. I'm going to rearrange this problem as e power x into logarithm of x. What is the differentiation of logarithm of x? 1 by x. I'm adding that and I'm subtracting 1 by x plus 1 by x squared. So I'm going to use some strategy here. So I'm going to split this question as e power x log x plus 1 by x. Okay. Plus integral of e power x is as 1 by x minus 1 by x squared dx. So can we use this formula now? Integral of f of x plus integral f dash of x dx can be written as e power x f of x. Yes or no? Just now we learned this. Same thing. So 1 by x is the differential of log x minus 1 by x squared is the differential of 1 by x. So the problem becomes e power x log x plus e power x 1 by x. Okay. Plus or minus, it is plus. So that's why the plus. I can take that common again. Log x plus 1 by x plus the constant c. That will be your answer. See, it can save our time without thinking about anything. Small improvisation of this equation will lead us to the answer. If I add 1 by x, it becomes integral of log x, and 1 by x squared is already a differential of 1 minus 1 by x. That's why it is directly applicable. And also by looking at the option, it gives a clue what to do here. Okay, if it is a multiple choice question, we can easily understand from the option, but if it is subjective questions, you should know how to get this. By practice only, you can remember this again. X square e power x. We have root of x square e power x dx. In our order, I, L, A, T, E. First comes algebraic, then this. So we are treating first function x square integral of e power x dx minus differentiation of x square is 2x into integral of e power x entire thing into dx. Okay, so what happened is x square into integral of e power x is again e power x minus this problem becomes 2x into e power x dx. Yes or no? So again we have to do one more time partial differentiation integration by parts. 2 I'm taking it outside. So we have x into e power x dx, right? So again by doing that x square into e power x minus 2 into x is the first function and integral of this integral of e power x into 1 dx. Okay, so this is the final answer x square into e power x minus 2x into e power x. Again, minus of minus become plus e power x entire thing plus c. So if we take e power x common, we end up with x square minus 2x plus 1 plus c. So you can also write it as x yes, x square x minus 1 whole square also we can write. Okay, so that's how we can solve this question. Let's erase this all.